Hello, I'm going to talk about parallel and perpendicular vectors. If we know if two vectors are parallel or perpendicular, that will be really helpful to know if two lines are parallel or perpendicular. Okay, two vectors or more are parallel when they have the same direction. So they can have different module or different magnitude, but they must have the same direction. So this could be like this or like this, different orientation, but the direction must be the same. They must be parallel. All right, that happens when they are proportional. Okay, that is easy to understand if you think about it. So if B and U are parallel, one of them can be written as a multiplication of the other times the number. K can be any real number. Here you have as an example. If imagine you have this vector. If you multiply it by 2, you obtain this one. These two vectors are parallel. If you multiply one vector, imagine it is this one, by 2, you just make it twice as long, all right? But it has the same direction. Or if you divide this one by 2, or if you multiply this one by 8, all of them are parallel. Okay, so if two lines have vectors, directional vectors that are proportional, that means that the directional vectors are parallel and the lines are parallel. All right? Now let's talk about perpendicular vectors. If two vectors are perpendicular, as shown in this picture, for example, between them there's an angle of 90 degrees. You know by trigonometry that the cosine of 90 degrees is 0. So the scalar product of these two vectors must be 0. Okay, a scalar product or dot product. It is without the s, sorry. Okay, so their scalar product or dot product must be 0. And you know that to calculate the scalar product, you have to multiply the x coordinates and then add the product of the y coordinates. So imagine with this example, I multiply 3 times 2 plus negative 2 times 3. This is 6 minus 6, that is 0. So these two vectors are perpendicular. All right, so an easy way to find a perpendicular of a vector is to change the coordinates and change the sign of one of them. Okay, so imagine we are working with the general equation of a line. Remember that this coefficient of the term x and this coefficient of the term y give us a perpendicular vector to the line. So if you want a directional vector of this line, you just have to change them and change the sign of one, and this is an example of a directional vector. Okay, I hope this video is useful for you. Thank you.